Thank you. I'm going to be talking about why it might be beneficial for you to join an open source community, what that involves, what type of communities there are, how you go about joining it, and some of the pitfalls that people often have when they first get involved with an open source community. So you need to start by finding something that's really your passion. It's a huge, huge opportunity out there. If you're interested in something technical, there's probably an open source community out there that is doing something in the space that you're interested in. So what do you like to do? What are you good at? I'll use the example of a distributed digital control system. Let's say that's your passion. Wow, I'm really interested in distributed digital control systems. And I got to tell you, I thought I made up that term a couple weeks ago when I worked on this slide, and then I looked it up on the internet, and there were 2 PhD theses written on that topic, so I tried. And let's say what you really like is system analysis. You know, I want to find out how I can instrument a distributed control system to find out, say, what's going on with latency. So how would you go about finding such an interesting project? One place, if you're on the software side, you can start is a site called sourceforge.com. I have a couple of projects there myself, as do 401,000 other people. It's a huge site. Lots of different technologies you can find there. And it's a very popular area for people to get the source code that's made available through that project. If you can imagine, there are 2 million downloads of projects off of SourceForge daily. So you really need to do your homework on those projects, because you'll find out the projects are what I will call stale or abandoned. So if you are looking for a project, some of the things that you should check for is look in the repository where the source code is in this case, if you're on SourceForge. When was the last time someone checked in a change? If it's been much more than a year ago, you can be pretty sure that there isn't really any good active development on that project. Most projects have mail lists where people ask questions, post information. If people are asking questions on the mail list, one of the things you should check for is anybody answering them? Is this a live, vibrant community? And if you find a project that interests you, you see that it's being actively worked on, you see that questions that are being posed are getting answered, that's a pretty good sign. You might want to dig a little deeper and see if it really matches what you're passionate about. So for instance, if you're interested in distributed digital control systems and you want to instrument an operating system, what you might want to do is find an operating system that is pretty small, pretty well engineered, and would be easy for you to pick up. Something a lot simpler than Linux or Windows. And so one of those that you might find interesting is NutX. And NutX is a presentation. There's a presentation tomorrow by Greg Nutt where you can learn a lot more about NutX. But that's an example of how you can go about finding a project that matches your interest. So what do? You've got a project that you think might be a good match. You have something that you're really curious about. What's the next step? Well, maybe you want to find out some hardware that it runs on. So I am a software engineer. I tend to focus a lot on the software, but there are lots and lots of open source hardware projects as well. One of the biggest ones that I see in the press a lot is Arduino, and it's a little board. I have $30. Someone says you can get it for $25. Really low cost. Maybe you want to pick up a few of these boards so you can hook them together and instrument the latency in this distributed control system. Maybe this board doesn't have all the power you need and you want to look at a more powerful board. So another board would be BeagleBoard, which I have a hunch Jason is going to mention tomorrow. I actually am showing the Panda board, which is a more powerful board than the Beagle board, but there's a lot of variety of different hardware out. So if you wanted to run full-blown Linux with some audio, video capture, streaming, hard disk, that type of thing, you might need a slightly more powerful board, but still the price is quite reasonable. And it's just not, and one of my favorite boards is called the Hawk board, and I'll talk about that a little bit more. And unfortunately, that project failed, and I will use it as an example of how not to run an open source project and the problem that they created for themselves. And then there are projects, lots and lots of hardware projects that are not related to just this single chip processor on a low-cost board. Here's an example of a printer called RipWrap, and it's a three-dimensional printer. And if you look at the white plastic pieces, you can actually print those pieces using this printer. So some people like to say it's self-replicating. Well, they're working that direction. I understand only about 30% of the parts that build up this printer can be printed by the printer itself. So there are lots and lots of projects that, depending on your interest, you can find some hardware to allow you to do it, some software if that's what you're particularly interested in. So although you should think big when you think about what open source project you want to get involved with, you should start small. If you come out and say, oh, I've got this great idea, we're going to rewrite all the software and we're going to do this, no one in the community will pay any attention to you because you haven't earned any credibility that you're going to do what you say. So one of the things that all open source communities like is when someone actually reads the documentation and you can make some improvements on it. How can you make this project easier, better explained, more valuable to the rest of the world? Try building the project. It's really hard for developers to build projects on all the different types of environments that are out there. So you might uncover some problems that they can't easily replicate because your build environment is different than their build environment. So build a project. If you have any problems, keep really close track of what you did and what went wrong. And then try it out and find out gosh, if it was really hard to use, what could you do to make it easier? And by looking at it from those points of view and giving that feedback, they will know that you're serious about it, that you tried it out, and that you are trying to give something back to the community. And so what really happens in open source projects is the first contact you make leaves a lasting impression. So you want to make that first contact one of being knowledgeable and being helpful, not of someone that just wants all the answers handed to them. So the most fundamental mistake people make when they get involved in an open source project is asking for help and how they go about asking for help. So my first recommendation on asking for help is don't. Try to figure it out yourself. Don't assume that after you spent 10 minutes of trying to figure out what has many engineering years of effort gone into it, that you're going to understand it all. It'll take more effort on your part. If you do have, a concern, I'm going to hit home again, read the documentation. This mug refers to that. There's lots of it says RTFM, which if you look through the archive mail lists, you might come across the acronym RTFM, so that's a good one to look up on Wikipedia to find out why that's such a common response. The other thing you need to do is search the mail list to make sure someone didn't ask the same question that you asked. You're having a problem. Why would you be the first person to have that problem? Somebody else probably had the problem. They probably asked. It probably got answered. So look for the answer. And if you ask a